So today we're going to do Unit 5, Lesson 6, Analyzing Graphs, and compare situations where quantities change exponentially. So in your warm-up, you need to look at this table and see if you notice any patterns. Some patterns that you might see is that each number is half of the previous number. You can get it by multiplying by 1/2 or dividing by 2. The non-zero digits of the decimals are powers of 5. So 5 to the first, 5 to the second, 5 to the third. We'll give you those decimal places. They can be written as fractions as well, and the denominators and the fractions are powers of 2. All right, so this first example we're going to look at is the value of cell phones changing exponentially. So we have phone A and phone B, and they're depreciating over time. Which phone is more expensive to buy when it's first released? And so we can figure this out just by looking at the graph. So for phone A, we would look at the initial value. So where it's crossing the y-axis there is going to be our initial value, and phone A is going to cost $1,000. For phone B, where it's crossing the y-intercept, is at 840. So those are the initial values for both phones. How does the value of each phone change with every passing year? Phone A and B are both depreciating, and you can tell by looking at the graph that phone A is depreciating more because it dropped from 1,000 to 600 in the first year. And so that's a difference of 400. And then phone B dropped from 840 to 630. So that is not quite as much. Which one is falling in value more quickly? Well, so if we want to explain this, we would look at the difference between the first and second year, the second and third year, and so on. So between the first, or the initial amount and the first year, it was a difference of $400. So you just take the value and subtract the next one, and you get 400. So that's the difference. And if we take 400 out of 1,000, it would simplify to 2/5 for us. So we've lost 2/5 of the value. If we do the same thing between the first and second year, we're going to find that it's also 2/5. It lost $240 that year. And that trend is going to continue. So to find the difference, you just find the difference of the Y values for each year. For phone B, you can do the same thing. So we're going to take 840 and subtract 630. And so you can see that it lost 1/4 of its original value. And then the next year, it lost 1/4 again. So each year, it's losing 1/4 of its value. Okay, if the phones continue to depreciate by the same factor each year, what will the value of each phone be 4 years after its release? So you're going to continue that trend. You can continue multiplying by 2/5 by the 216 that we have at year 3 and get a total. Or if we want to know how much is left without having to subtract it from that original amount again, we can just multiply by the fraction that's left. So if we're depreciating by 2/5 each time, and we want to know how much is left, we can just multiply by the difference. So 1 minus 2/5 would give us 3/5. So instead of multiplying and subtracting, we can just multiply that factor by what's remaining and get our answer. So 3/5 times 216 is going to give us 129.60. And then we can do the same thing for phone B. Instead of multiplying by 1/4 and subtracting it, we can multiply by 3/4 and get our answer there. If we wanted to find out how much the phone would depreciate over any number of years, we could write an equation. So our equation, we would use the value that's remaining and then multiply it by the initial value. So we already said our initial value for phone A was 1,000, and it was depreciating 2/5. So I want to multiply that by a growth factor of 3/5, and then I can raise that to the exponent for whatever number of year that I'm looking for. For phone B, our initial value is 840, and our growth factor would be 3/4. So we're going to multiply by 3/4 for that one and raise it to the power of t. All right. So here we have some cards, and this question is going to be on your practice problem. So the value of company stock doubles approximately every 4 years, and we're going to match that to card 7. You can see if you look at 0 year, it's at 100. And then if you go up to 4 years, it has doubled and it's now at 200. If you look at 8 years, you can see that it's doubled again and it's now at 400. And that trend would continue. Card 2, if a car is losing 1/4 of its value every year, we would match that with card 3. You can see that at year 0, it's there, and then it goes down 1/4 of its value every year. Okay, card 5, the company's stock triples roughly every 8 years. So we would look at every 8 years to see if it's tripling. And then for card 6, a laptop is losing 1/3 of its value after every year. So it's the only other card that is decreasing. So we would look at that just to make sure that it's losing that amount every year. All right, so just to recap, we are looking at the initial value times the growth factor that is remaining. So it's either a percent turned into a decimal or the fraction of the part that is remaining, not what's being taken away, and then raising that to the power that we're looking for.